Friends, we all know that uh, in your household refrigerator, R134a is the refrigerant which is used. It is the fluid which is responsible for giving the cooling effect in the freezer section of your household refrigerator and in the compartments where you preserve your vegetables and other food stuff. Uh, this presentation is to understand why R134a is a popular choice nowadays, and also to understand what would it be replaced with. We need to have a historical perspective as to how the refrigerants are being uh, evolving. So earlier, as you see in the slide, in the 1960s onwards, for at least 2 decades, the popular choice was chlorofluorocarbons. Uh, then, uh, especially in the developed world, the chlorofluorocarbons were banned totally and they were replaced with hydrochlorofluorocarbons. And the era of HFOs and natural refrigerants are the recent phenomena because these HFOs and the natural refrigerants are most environmental friendly. Uh, as far as domestic refrigerators are considered, earlier R12, as the name indicates, it is R12 means 012, that is the number of carbon atoms is 1, 0 plus 1 is 1. It is a methane derivative, so it is a difluoromethane. This R12 was used in household refrigerators because of its excellent thermodynamic and excellent chemical properties. However, because it contained chlorine atom, it was to be phased out. And then R12 was gradually phased out in the developed world with R134a. 1 stands for 2 carbon atoms in 134a, and hence it is a ethane derivative. So it is a tetrafluoroethane which replaced the dichloro-difluoromethane in your household refrigerators. So now in India, for example, we find that refrigerators use R134a. In the developed world, even this R134a has been banned and has been replaced with isobutane as well as hydrocarbons. Uh, but the focus of the discussion would be R134a, and we would also touch upon the other refrigerants like R600a, which is isobutane. This shift is nothing to do with the thermodynamic or chemical properties. This shift is largely or solely actually uh, because of the environmental reason, namely the ozone depletion potential of R12, which is significant. Why R134a replaced R12? Because R134a had similar properties, similar thermodynamic properties, as well as similar chemical as well as safety related properties, that is physical properties similar to R12. So that is why R134a became the ideal choice. For example, the normal boiling point of R134a is also much lower, that is, it is also minus 26 degrees centigrade at 1 atmosphere, which is ideal for your freezer section and fresh food section of your refrigerators. Also, the latent heat of vaporization is excellent in case of R134a. Because the refrigerant has to be used in household refrigerators, R134a being a A1 class ASHRAE A1 class refrigerant, which means that it has a low toxicity and it is not at all flammable, that's had a major disadvantage over the other flammable hydrocarbons. So that was the reason why R134a became a popular choice. Uh, as I said, it replaced R12. R12 was having ozone depletion potential, uh, and R134a was ideal because R134a has a zero ozone depletion potential, vastly superior to R12's severe ozone damage. So that was an important reason why R134a replaced R12. With R134a and minus 26 degrees centigrade normal boiling point, uh, and suitability or compatibility with the hermetic compressors, we had moderate evaporating pressure and moderate condensing pressure. That is, the pressure ratio was manageable with R134a. And if the pressure ratio is more manageable, the volumetric efficiency is good, the discharge temperature is lower. So that was another advantage with R134a. As we mentioned earlier, the latent heat of vaporization was also very good, and the performance was fairly stable with R134a. Chemical and material compatibility was also very good because it was found to be not at all corrosive. It was compatible with copper, with aluminium, as well as the steel, the common materials which are used in the refrigerator construction. Chemical stability was good with R134a because in the temperature range which the domestic refrigerator encounters, R134a was found to be chemically stable and hugely reliable. The lubricant, which is POE, polyol ester oil, uh, it has a good lubrication properties, and those lubrication properties were found to be compatible. Uh, the oil was found to be compatible with R134a. Uh, if you compare R134a with R12, you will find that the properties are fairly similar. I mean, the thermodynamic properties are fairly similar. Look at the boiling points, R134a minus 26 and R12 minus 29.8. Flammability, both are non-flammable, and uh, the energy's coefficient of performance is also comparable. The advantage which R134a had was because it is a hydrofluorocarbon and not a chlorofluorocarbon. The absence of fluorine meant that the ozone depletion is zero, whereas R12 had a ozone depletion of 1, very high. The global warming potential is also low, significantly lower than R12, which had a global warming potential of around 10,000, whereas that of R134 is only 1430. And hence, because of its favorable environmental properties, R134 became a popular choice.